Hey guys, today we're going to do chapter 3, section 4, derivatives of inverse functions. As you can see, a couple things are already highlighted for you. A couple things are already filled in. A function y equals f of x that is 1 to 1 will pass the horizontal line test, and will therefore have a unique inverse function y equals f negative 1 of x. So the main thing we're looking at here for example number 1 is the graph of f contains the point AB, and then the inverse contains the point BA. So what we've done here for example number 1 is labeled our chart in columns 1, 2, and 3. So for f, the inverse of f negative 1 of x, you would switch columns 1 and 2. So 2, 3, negative 1, 1, and 4, negative 1. For the inverse of g, you would switch columns 1 and 3, negative 1, 3, 0, 1, and 3, negative 1. And now for C through F, we're going to use those charts to help us find our inverses. So F of the inverse of G of 0. So I'm going to start by finding the inverse of G at 0. So I'm going to look at this chart. Inverse of G at 0 is 1. And F of 1 is negative 1. So for part D, F of negative 1 is 4. And the inverse of F at 4, inverse of F at 4 is negative 1. All right, the inverse of G at negative 1. The inverse of G at negative 1 is 3. The inverse of F at 3, notice 3 is not in our table, so this does not exist. And we'll just say because it is not defined in the table. All right, the inverse of G, the inverse of F at 4. The inverse of F at 4 is negative 1. And the inverse of G at negative 1 is 3. The existence of an inverse function. A function has an inverse if and only if it's 1 to 1. One piece of the domain goes with one piece of the range. If f is strictly monotonic on its entire domain, that means it's either all the way increasing or all the way decreasing, then it's 1 to 1 and therefore has an inverse function. So what you see here, and you guys are going to want to pause your video, is the proof to why f of the inverse of f is equal to x. And so what we've done here is derive the formula of finding the derivative of an inverse function. So again, pause your video, get that down, and we're going to use that in example number 2. Given f of x equals 4x minus 3 and f prime of 2 is equal to 4, find the inverse of f at 5 and the derivative of that. So the first thing we're going to recognize is that this is going to be a y value. The inverse is going to indicate a y value because remember xy is your normal function, yx would be your inverse. So we're going to set, because f of x is equal to y and y is 5, we're going to set our function equal to 5. So 4x minus 3 is equal to 5, and we're going to solve for x. So 4x is 8 and x is equal to 2. So here's how we're going to deal with that x equals 2. That means f of 2 is equal to 5. In our function, plug in a 2 and you get 5. So what we're going to do for the inverse is we're going to switch these two. So what that looks like is f negative 1 of 5 is equal to 2. And I'm going to show you how we're going to use that in our formula, which we just derived here at the top of the page. So what we're looking for, the inverse of 5 prime, is, according to our formula here, 1 over f prime of f negative 1 of 5. F negative 1 of 5 is 2. So let's color code that so you guys can see where all these numbers are coming from. So that's 1 over f prime of 2, and f prime of 2 is 4. So your answer is 1 over 4. So a couple of things I want to add here. F prime of 2 is 4. F prime of 2 is 4. And then one last thing, slopes of inverses are reciprocals of each other. All right, to find the derivative of an inverse function, you're going to want to follow these steps. And if you follow them very closely, it will get you to your answer. So we're going to start by finding f prime. If you're only given b, set b equal to f of x to find a. Find f prime of a. G prime of b is 1 over f prime of a. And then there's our inverse formula for the derivative. So in example 3, we have a chart. G is the inverse of x. So if g is the inverse of x, we're going to go backwards here for our point. And remember what we just wrote about the reciprocals of inverses. So we're going to do, for this column, we're going to do the reciprocal of f prime of x. So the reciprocal of 0 does not exist. The reciprocal of negative 4 is negative 1/4. And the derivative of 6, the reciprocal of 6 is 1 over 6. We're looking for g prime of negative 1. So we're going to focus here, g prime of negative 1. So g prime of negative 1 is going to be 1 over f prime of 3. And f prime of 3 is negative 4. So a lot of substituting, a lot of possibly feeling like you're going in circles. You kind of are. Just make sure you know which circles you're heading in and that you're heading in the right direction. All right. Let g be the inverse of f. Calculate g prime of negative 9 for f of x equals 4x cubed plus 5x. And you're going to need a calculator for this one. We're going to follow the steps at the top of the page. Step 1 is find f prime of x. So 12x squared plus 5. We're only given b. If we set this equal to negative 9, we're not going to be able to figure that out because of the cube with no squares, not factorable. So what we're going to do is we're going to take this function. We're going to graph it to find the point where y is equal to negative 9. We're going to use the table function. And that's going to give us our ordered pair, A, B. We already know B is negative 9. Now we just need to find A. So we're going to graph 4x cubed plus 5x On the graph, we don't really have to see the graph. We just really need the table function. And we need to know where y is -9. There it is. Y is -9 when x is -1. Now, according to the steps at the top of your page, we have found A. We need to find f prime of A. So f prime of A is f prime of -1, which is 12 times -1 squared plus 5, which is 17. So g prime of -9 is 1 over f prime of -1, which is 1 over 17. Example 5, also need a calculator. If f of x is 4x to the 7th minus x squared plus x minus 5, find the derivative of the inverse at 3, accurate to 3 decimal places. We are only going to go accurate to 3 decimal places once we get to the very end in our answer. This problem very nicely gives you the steps and tells you exactly what you need to do. All right, so solve f of x equal to 3. This will give you x equals a. All right, so we have for step 1, f of x equals, and we're going to set it equal to 3. So what that looks like is 4x to the 7th minus x squared plus x minus 5 equals 3. 4x to the 7th minus x squared plus x minus 8 is equal to 0. That is going to be y sub 1, and y sub 2 is going to be 0. Because what we're going to do is trace that intersection to find our x value. Remember, no rounding until the very end. So 4x to the 7th minus x squared plus x minus 8, y sub 2 equals 0. If you're not familiar with these calculator commands, you might want to make some additional notes. We need this value of x. So second trace 5. We're going to find the point of intersection between the blue and the red graphs. Basically, we're finding the x-intercepts. When you put y sub 2 in your calculator equal to 0, it helps you find the x-intercepts exactly. Again, we're not rounding. So what we found is that x equals 1.1063959. So there's step 1. In step 2, differentiate f of x, so find f prime, which is 28x to the 6th minus 2x plus 1. And evaluate f prime of a. Well, this is a. So f prime of 1.1063959, and again, we're not rounding. Here's how we do that from this graph. You see that number is already stored in x? So x, second quit, type in x and enter, and it's in there for you. So we're going to type in our derivative, 28x to the 6th minus 2x plus 1, and f prime of a is 50.1467736.4. So to find the value that we're looking for, use your result to find g prime of b, which is going to be our inverse derivative. So f -1 of 3 prime is 1 over that value. And this value we will round to 3 decimal places. Now to type that into your calculator, you do 1 divide and I want that value, so I hit second negative. That's 1 divided by the last answer. And we get 0.0, and I guess we should say 0.020. 0.0199, if it asks for an additional place, would work as well. Now we're going to go to derivatives of other bases. So you've had lots of experience with derivative formulas, and now here are additional ones. If your base is a number to the x power, natural log of a times a to the x. So we're going to use that for part A. So y prime is just ln of 3 times 3 to the x power. That's it. You're done. There's nothing else to do there. For this problem, we're going to do a rewrite. I'm going to make 4 be 2 squared, which is 2 to the 6x power. And I'm going to evaluate that. Y prime equals 2 to the 6x power. And I just did that part first. I'll go ahead and do my ln2 and then times the derivative of 6x, which is 6. And then just rewrite 6 ln2 times 2 to the 6x power. Again, you're multiplying, so the order really doesn't matter. 5 to the x squared, y prime, equals ln 5 times 5 to the x squared times the derivative of x squared. So 2x ln 5 times 5 to the x squared. And then dy prime ln 5 times 5 to the 3 minus x squared times negative 2x. Negative 2x ln 5 times 5 to the 3 minus x squared. On the next page, we're going to be looking at y equals log base 5 of x. So we're going to be using this formula here. Y prime equals 1 over ln 5 times x, 1 over x ln 5. For B, y prime. So we're looking at log base 3 of sine of x. This one has an additional derivative that we have to look at. So we're going to do 1 over ln of 3. And again, looking at that derivative formula, 1 over ln 3. And then we're going to extend that times sine x times the derivative of sine x, which is cosine x. So we have cosine of x over sine x times ln 3. And again, order on the bottom is not going to matter. Base of 10 for part C, so y prime equals 1 over ln 10 times the function times the derivative of the function. So that's 1 plus, and then the derivative of 3 to the x is ln 3 times 3 to the x. So your answer is 1 plus 3 to the x ln 3 over ln 10 times x plus 3 to the x. Cube root of 2x plus 1 is 2x plus 1 to the 1/3 power. So y prime, again, we have our log base 2, so 1 over ln 2 times the function times the derivative, 1/3 bring down, minus 1 times the derivative of the inside. And then just clean that up. You've got 2 on the top. You've got this on the bottom. And then you've got your other pieces here on the bottom as well. So let's do 3 ln 2. And then you've got 1/3, and you bring the 2/3 down, and 1/3 plus 2/3 is just 1. Example 8, find an equation of the tangent line of f of x equals 6 to the x power where x is equal to 2. So f prime is ln 6 times 6 to the x power. F prime of 2 finds our slope. So ln 6 times 6 squared. And I'm going to use my calculator and not round. So ln 6 times 36 is 64.50334089. And my point is going to be 2 and then 6 to the second power, which is 36. So I'm going to actually do 2 tangent lines here. I'm going to show you what they look like, the exact and the approximate. The exact is going to use the ln format. So y equals slope is going to be 36 ln 6 times x minus 2 plus 36. And the approximate is going to be that value here. Because remember, your calculator will only go so far. Example number 9. A bacteria is growing according to the function W of t for t greater than or equal to 0, where W of t is the weight of the culture in ounces and t is in hours. Find the weight of the culture after 0 hours, 2 hours, 8 hours, and what is the limit as x approaches infinity. So we're going to find W of 0, W of 2, and W of 8. Now 0 we can just plug in because e to the 0 power is 1. So we have 1 plus 0.3, 1.3 over 1.3 over 1.3 is just 1. But for these others, I'm going to store the 2, 1.3 divided by parentheses, 1 plus 0.3 e to the negative 0.4x, and I get this value, which I'm going to write down for W of 2. And then store the 8 and type in your same function. So as you can see, those numbers are getting closer to, because 8 is going to be kind of our biggest hour here. I mean, we could go ahead and do 9 and 10 because we're looking for the limit as t approaches infinity of the function. And we could graph that as well. And we would see that it approaches 1.3. And as you can see for 8, it gets very close to 0.3. What the graph looks like is, you can see it's getting closer and closer and then plateaus. And that plateau would be right around 1.3. So this is the carrying capacity of a logistic growth behavior model. Just some extra information for you there. All right, heading over to example 10, we have a table here for us to look at. So our formula, and we are going to switch our columns. Here is G, X, and G. So the inverse of G is going to flip these two. So 5, -3, -1, 0, -3, 2, and 2, 4. Use the table at the right. Find each of the indicated values below. State the ordered pairs for the inverse function G, -1 of X in the column provided. So here's the formula that we're going to follow in order to find our answers here. So F, the inverse of F at 4 prime is going to be 1 over F prime of the inverse of F at 4. All right, so the inverse of F at 4, I'm sorry, the inverse of F at 4 would be 2. So we can look here because G is going to be our inverse. So we can look at here in this last column. 4 is 2. And 1 over F prime of 2 is 1. 1 over 1 is 1. So I'll walk you through that one again. The inverse of G prime deals with F prime. So F prime of F -1 of 4 is 2. F prime of 2 is 1. All right, part B, inverse of G -3 prime, 1 over G prime, inverse of G of -3. So because we were looking at F here, we kind of read these backwards. Because we're looking at G, we're going to read them forwards. So 1 over G prime of -3 would be 2. And 1 over G prime of 2 is 2, so 1/2. Write the equation for the tangent line tangent to the graph of the inverse of G when X is equal to 2. So G prime, excuse me, G -1 of 2, G -1 of 2 is 4. Inverse of G prime is going to be 1 over G of the inverse of G at 2. So 1 over G prime of 4 is -3. So that's going to be our slope. And then the point would be 2, 4. So the tangent line would be y equals -1/3 times x minus 2 plus 4. Estimate the value of g prime of 3. Use the result to explain the behavior of the graph of the function g when x equals 3. So g prime of 3, we're going to do g of 4 minus g of 2 over 4 minus 2. So looking back at your chart, g of 4 is 2. G of 2 is -3 over 2, 5/2. So since G prime of 3 is greater than 0, 5/2 is greater than 0, the graph of G of X is increasing at X equals 3. This concludes section 4 of chapter 3. As always, if you have any questions, let me know, and I'll talk to you soon.